So next in right triangle trigonometry, we're going to have special triangles. That is, if we have the angles 30 degrees, 45 degrees, 60 degrees, or if we're dealing with radians, pi over 6, pi over 4, and pi over 3, give special values for trigonometric functions. And so just like we learnt with the unit circle, and these are all can be used with the right triangle. So if these have a length of 1, and let's say we're dealing with the 45 degrees, so we have 45, 45, then using Pythagorean theorem, this length is square root of 2. And then if we have another triangle, an equilateral triangle where each of these sides has a length of 1, then each angle is going to be 60. But if I half this triangle, and let's say just focus on maybe the left half, and so just like with this other square, we're just focusing on one piece. So now if we focus on that, we're cutting it in half. Now we have a right angle. The upper angle used to be 60 degrees, but when I cut it in half, now it's 30 degrees. So basically like we're folding this equilateral triangle together. And the base used to be 1. Now we have 2 separate pieces of 1/2. And so, if we have, I don't know, we'll call this y. And using Pythagorean theorem, we can solve for y. 1/2 squared plus y squared equals 1 squared. 1/4 plus y squared equals 1. And then we'll subtract 1/4. So y squared is 1 minus a fourth, or 3/4, and then when we take the square root, we get y is the square root of 3 over the square root of 4, and square root of 4 is 2. So this length is root 3 over 2. And so that would give us our right triangle, and then we can use our ratios to get the following. So we will have theta, and let's make theta be in degrees. We'll also have theta measured in radians. Then we'll have the value of sine of theta, cosine theta, and tangent of theta. And we'll start off with 0 degrees or 0 radians. And so for this one, well, just like with the unit circle 0, 1, 0, we have sine, which is opposite. So how far up we're going? Well, if we're straight, we have no angle. We're right here, we have no height. 30 degrees, we can refer to our pictures up here. And so if we're dealing with the 30 degrees, we reorient ourselves from up here, opposite over hypotenuse. So that will give us, that gives us the following. So at 30 degrees, or pi over 6 radians, sine is 1/2. Cosine would be adjacent. That would be root 3 over 2. And then tangent, we would end up with root 3 over 3. Okay. Just using these triangles. 45 degrees. So at 45, here we go. Sine is opposite. 1 over root 2. You get 1 over root 2. which if we rationalize it, we're left with root 2 over 2. Cosine is going to be the same, and then tangent is opposite over adjacent. So just using this, we will go ahead and just fill this all out. Pi over 4, root 2 over 2, root 2 over 2, 1. 60 or pi over 3, we get root 3 over 2, 1 half, root 3, and then at 90, we get pi over 2, 1, 0, and the tangent is undefined. And so these are the same values that we got from the unit circle. In fact, we could continue going on if we did the other three trig functions, cosecant, secant, and cotangent. But we're just going to be just looking at this. You may also notice that we sort of have sine 0, cosine is 1, and then sine is 1 half, cosine is 1 half, root 2 over 2, root 2 over 2, root 3 over 2, root 3 over 2, 1, 0. So it's sort of like this opposite. It goes from 0, 1 half, root 2 over 2, root 3 over 2, 1, and then cosine goes in the opposite direction. So, that's no coincidence. So in fact, what we get are things like sine of 0 degrees is equal to cosine of 90 degrees. Sine of 30 degrees is cosine of 60 degrees, and so forth. Sine 45 equals cosine 45. Sine 60 is cosine 30, and then sine 90 is cosine of 0. Now, the three angles in a triangle sum to 180 degrees or pi radians. So looking at a triangle, if we have a right triangle, we already know that one of the angles is going to be 90. That means that the other two angles, so let's call these other two angles let's call these other two angles, so our base angle will be alpha, and then the angle on top would be beta, and let's say the opposite side is A, the adjacent side is B, and our hypotenuse is C. This is all if we're looking at alpha. So in a triangle, we know that the sum of the three angles is 180 degrees. One of them is already a right angle, so that's 90. Then we also have our alpha and our beta. So if I subtract 90 degrees, we're left with 90 degrees is alpha plus beta. And so alpha and beta are complementary angles. And that's what we're getting right here. We're having sine of 30 and 60, 45 plus 45, 60 and 30, 90 and 0. So I hope you're starting to see what's happening. Now, what we get with this triangle is we can describe our angle sine of alpha. Sine of alpha is our opposite over hypotenuse. In this case, the opposite for alpha is A, and the hypotenuse is C. Now, if we look at cosine of beta, so this is the angle that's on top. We're now going to be dealing with, in terms of beta, cosine is adjacent over hypotenuse. So what is adjacent to beta is the side A. and then the hypotenuse is C. So both of these are describing A over C, but depending on which angle, A is either opposite or adjacent. And so what we can conclude is that sine of alpha is equal to cosine of beta. So in fact, what we have here is we have that these angles are called cofunctions because of this relationship between their complementary angles. And so we have a bunch of cofunction relations. And so what we're going to do is, since we knew from up here that our alpha plus beta was 90 degrees, let's rearrange, like subtract beta or alpha from both sides. So beta is 90 degrees minus alpha. We'll substitute that into here. And so we get sine of alpha is cosine. Instead of beta, we write 90 degrees minus alpha. So that's sort of this relation that we have. And so what we get now are a set of cofunction identities. And the cofunction identities in degrees are as follows. Sine of theta is equal to cosine of 90 degrees minus theta. Cosine of theta is equal to sine of 90 degrees minus theta. And then tangent of theta is equal to cotangent of 90 degrees minus theta. Cosecant of theta is equal to secant of 90 degrees minus theta. Secant of theta is cosecant of 90 degrees minus theta. And then cotangent of theta is tangent of 90 degrees minus theta. So we have those relations. And then if we were in radians, it's the same thing. 90 degrees in radians is pi over 2. So we get sine of theta is equal to cosine of pi over 2 minus theta. Cosine of theta is sine of pi over 2 minus theta. Tangent of theta is cotangent of pi over 2 minus theta. Cosecant is secant of pi over 2 minus theta. Secant of theta is cosecant of pi over 2 minus theta, and then cotangent of theta is tangent of pi over 2 minus theta. So these are our cofunction identities. So if we're to do a quick example, and we made the substitution, let's say let theta equal 0 degrees. So we're going to have sine of 0 is equal to cosine of 90 degrees minus 0 degrees, which is cosine of 90 degrees. So we have sine of 0 is cosine of 90 degrees. Similarly, we would have sine of 60 degrees. Rather, let's do 30 degrees first. 30 degrees, that would be cosine of 90 minus 30, which would give us cosine of 60 degrees. So sine of 30 is cosine 60. Sine of 45 degrees would be cosine of 90 degrees minus 45 degrees, which gives us cosine of 45 degrees. Again, These are the numbers that we just saw in that table just above. Sine of 0 degrees is cosine 90. Sine of 30 degrees is cosine 60. Sine of 45 degrees, cosine 45. Sine of 60 degrees is cosine of 90 degrees minus 60. 90 minus 60 is 30 degrees. So sine 60 is cosine 30. And then finally, we have sine of 90 degrees is cosine of 90 degrees minus 90, which is 0. These are the values that we got from that table. So now we've actually explained that symmetry that we got from up here. And that's because of cofunctions. Right. And so one last thing from this trig table is that you might notice there is a nice pattern to this in addition to the cofunctions. But what we can do is let's just focus right here on just the sine and the cosine. So we're just going to look at just these two. So if we have theta, and we'll put theta both in degrees and in radians. So we have 0 degrees, 0 radians, 30 degrees, pi over 6, 45 degrees, pi over 4, 60 degrees, pi over 3, and then 90 degrees, pi over 2, sine of theta, and then cosine of theta. We can think of sine as, let's say, the square root of 0 over 2. Sine of 0, sine of 30 would be the square root of 1 over 2, square root of 2 over 2, square root of 3 over 2, and square root of 4 over 2. This first one, square root of 0 over 2 is just 0. Square root of 1 is 1. Divided by 2, 1/2. Root 2 over 2, that's the same. Root 3 over 3, root 3 over 2 is the same. And square root of 4 is 2. 2 over 2 is 1. So that's what we had in our original column. And then now we use the cofunction and we just write it in reverse. So cosine theta is root 4 over 2. Cosine at 30. So cosine at 0 is root 4 over 2. At 30 is root 3 over 2. At 45 it's root 2 over 2. At 60 it's root 1 over 2. And then at 90 it's square root of 0 over 2. So this is another way of looking at this trig table, and it might help you memorize it.